The largest dog that ever lived was not an ancestor of any dog alive today. Epicyon haydeni, which roamed North America from approximately 15 million to 5 million years ago, weighed somewhere between 100 and 170 kilograms, depending on the individual. Heavier than a modern lion, comparable in mass to a large grizzly bear, and built with a skull so broad and jaws so powerful that it could crack the bones of the large animals it hunted the same way a spotted hyena does today. It looked like a dog. It was classified within the family Canidae, the same family that contains wolves, foxes, jackals, and the domestic dog. It lived on the same continent, in the same ecosystems, at the same time as the small, fox-sized ancestors of the animals we now call dogs. And when Epicyon went extinct at the end of the Miocene, approximately 5 million years ago, it left nothing behind. No descendant species, no surviving lineage. The most powerful canid that ever evolved was an evolutionary dead end, and the ancestor of every living dog was a timid, unimpressive animal that lived in its shadow for millions of years. This is the central puzzle of Epicyon's story, and the reason it matters beyond the usual fascination with large, extinct predators. We are accustomed to thinking of extinction as the death of something that failed, an animal that could not compete, could not adapt, could not hold its ground against something stronger or better suited to its environment. Epicyon did not fit that narrative. It was dominant. It was anatomically sophisticated. It had been doing what it did for 10 million years. And it vanished without a trace in the genetic record, while the unimpressive little canid living quietly in the background of the Miocene ecosystem became the gray wolf, and eventually the domestic dog. Epicyon belonged to a group called the Borophaginae, a name that translates roughly as glutton eaters, referencing their bone-crushing feeding behavior. The borophagines were a major radiation within the canid family that produced over 60 species across approximately 30 million years of evolutionary history, from roughly 33 million years ago in the late Eocene to approximately 5 million years ago at the end of the Miocene. At their peak diversity in the Miocene, borophagines were the dominant carnivore guild in North America, filling ecological roles ranging from small, omnivorous foragers to large, hypercarnivorous apex predators. The smaller borophagines resembled raccoons or small bears in their dietary flexibility and dentition, animals like Synarctus and Tomarctus, which were generalists capable of eating fruit, insects, and small vertebrates in addition to larger prey. The medium-sized borophagines, such as Ailurodon, were more committed meat eaters, with longer legs suggesting greater cursorial ability. The larger ones, the genus Epicyon and its close relative Borophagus, were specialists in hard object feeding, with premolar teeth modified into crushing tools capable of breaking large bones to extract the marrow inside. This is a dietary strategy that requires a specific set of skeletal and muscular adaptations. A shortened jaw for increased mechanical advantage, thickened premolars that resist fracture under high loads, and enlarged jaw-closing muscles that attach to a broader, more robust skull than any running predator could afford to carry. The borophagines evolved all of these independently from every other carnivore lineage that developed bone-crushing capability, and they did so across multiple species and multiple time periods. The bone-crushing adaptation evolved more than once within the borophagines themselves, as the lineage repeatedly converged on the same successful strategy. Epicyon haydeni, the largest species in the genus, is known from fossils found across the American West, California, Oregon, Nevada, Nebraska, Kansas, and Texas, and represents the extreme end of the borophagine body size trend. The genus Epicyon appears in the fossil record approximately 12 million years ago, and persists until the genus Borophagus replaces it approximately 7 million years ago, with Borophagus itself surviving until approximately 5 million years ago. The skull of Epicyon haydeni is one of the most striking objects in North American paleontology. It is wide and deep relative to its length in a way that looks almost wrong for a canid, more reminiscent of a hyena or a bear than of a wolf. The zygomatic arches, the cheekbones, flare outward dramatically to accommodate the large temporalis muscles that provide the bite force. Bite force estimates for Epicyon haydeni, based on the geometry of the skull and the cross-sectional area of the jaw muscles, place it among the highest bite forces recorded for any canid, well above modern wolves and gray wolves and comparable to estimates for spotted hyenas. The carnassial teeth, which in most carnivorans function as the primary shearing tool for processing meat, are present but reduced in relative size compared to the crushing premolars, indicating that Epicyon was more focused on processing bone and sinew than on slicing flesh cleanly. This dentition pattern, reduced carnassials, enlarged crushing premolars, is the signature of a durophage, an animal specialized for hard food processing, and it appears in the fossil record as a highly consistent feature across all large borophagines. Every specimen of Epicyon haydeni ever found shows this same dental architecture. The specialization was fixed, thorough, and ancient by the time Epicyon reached its maximum size. The ecological role Epicyon played in Miocene North America has a direct modern analog, and the parallel is striking precisely because it involves a completely unrelated animal. The spotted hyena, Crocuta crocuta, of sub-Saharan Africa is not a dog. It belongs to the family Hyenidae, which is more closely related to cats and mongooses than to canids. But the spotted hyena has evolved the same bone-crushing jaw architecture, the same shortened skull, the same enlarged crushing premolars, and the same behavioral strategy of processing carcasses by cracking bones that other predators cannot exploit. Hyenas and borophagines arrived at nearly identical functional solutions to the problem of accessing bone marrow through completely independent evolutionary paths on different continents separated by millions of years. This is convergent evolution at its most exact. Not just a superficial resemblance in shape, but the same structural modifications in the same anatomical elements for the same dietary purpose. When Epicyon and the borophagines went extinct, the bone-crushing ecological niche in the world's carnivore communities did not disappear. It was already filled in Africa by hyenas, and it was waiting to be filled in North America by whoever colonized the continent next. Spotted hyenas themselves never reached North America in significant numbers. The niche remained partially vacant after the borophagines disappeared. The Canid family tree, as established by molecular phylogenetics and confirmed by genomic studies, divides into three major groups. The Hesperocyaninae were the earliest canids, first appearing approximately 40 million years ago and going extinct approximately 15 million years ago, leaving no descendants. They too were an evolutionary dead end, a full 30 million year lineage that vanished entirely. The Borophaginae radiated from the Hesperocyaninae and dominated for 30 million years before going extinct entirely 5 million years ago. The Caninae, the third group, are the only canid subfamily with living members, and every living canid, from the gray wolf to the fennec fox to the African wild dog to the domestic dog, belongs to this lineage. The split between Borophaginae and Caninae occurred approximately 35 to 38 million years ago, meaning that for most of the time Epicyon existed, the lineage that would eventually produce wolves and dogs was already on a completely separate evolutionary branch. Epicyon and the ancestors of modern dogs were not related to each other in any especially close sense beyond being members of the same family. A relationship comparable to the relationship between a modern horse and a chalicothere, an extinct perissodactyl that went extinct a few million years ago and that any horse-literate observer would recognize as something very different despite the family connection. Calling Epicyon an ancestor of the dog because both are canids is like calling a rhinoceros an ancestor of a horse because both are odd-toed ungulates. The family connection is real. The ancestry is not. The molecular phylogeny of living canids was substantially clarified by the publication of the domestic dog genome in 2005 by Kirsten Lindblad-Toe and colleagues, published in Nature. The Dog Genome Project sequenced the complete genome of a female boxer and compared it to the genomes of other mammals, establishing the genetic architecture of the canid lineage and providing a reference for subsequent studies on wolf domestication, canid diversity, and the evolutionary relationships among living species. One of the results of this work was a precise estimate of the divergence time between canid lineages based on rates of molecular evolution, confirming that the split between the ancestors of wolves and foxes occurred approximately 12 to 15 million years ago, during the period when Epicyon was still alive and dominant in North America. Wolves and fox lineages were diverging while Epicyon was walking the same continent. Subsequent phylogenomic studies using genome-wide data confirmed what the fossil record suggested. The Caninae diversified rapidly in the late Miocene and Pliocene, with the major canid lineages, wolves, foxes, South American canids, African wild dogs, diverging from each other between approximately 10 and 3 million years ago, precisely during and after the period when the borophagines were declining. The timing is not a coincidence. As the large borophagines disappeared, the ecological space they occupied opened up, and the Caninae, already present in North America as small generalists that had coexisted with the borophagines without directly competing with them, began diversifying into larger body sizes and more specialized hunting strategies. The wolf, the apex canid predator of today, is in some sense the Caninae's answer to a niche that the borophagines vacated, a delayed filling of the space left by animals that had dominated it for 30 million years. The question of what killed the borophagines has been debated for decades in paleontology, and the answer appears to be a combination of factors that converged at the end of the Miocene. The late Miocene and early Pliocene, from approximately 8 to 5 million years ago, was a period of significant global climate change, cooling and drying that restructured ecosystems across the northern hemisphere. In North America, the expansion of open grasslands at the expense of woodland and mixed environments changed the prey base available to large predators. The large grazing animals of the early and middle Miocene, the three-toed horses, the browsing rhinos, the giant peccaries, were being replaced or reduced in diversity by different fauna adapted to open grassland conditions. The horses were evolving longer legs and higher-crowned teeth suited to grazing tough grasses rather than browsing soft vegetation, making them faster and harder to ambush. Large cursorial predators capable of running down prey across open ground were favored over ambush specialists and bone crackers adapted to processing carcasses in woodland environments. The borophagines, which appear to have been less cursorial than the Caninae based on their limb proportions, shorter legs relative to body size, heavier build, a body plan optimized for power rather than speed, may have been progressively less able to exploit a prey landscape that was becoming faster and more open. The bone-crushing specialization that had been a competitive advantage when large carcasses were abundant became a liability when the animals producing those carcasses became scarcer and harder to catch. A second factor was the arrival of felids. True cats, the family Felidae, first appear in North America in the fossil record approximately 8 to 9 million years ago, having crossed from Asia via the Bering Land Bridge. The large felids that colonized North America in the late Miocene were efficient ambush predators with retractile claws, highly developed binocular vision, and a killing bite targeted at the neck or skull of prey rather than the sustained pursuit strategy of pack-hunting canids. They competed directly with borophagines for large prey, and they were better designed for catching it in the open grassland environments that were expanding across the continent. A felid chasing a horse across open ground is faster and more agile than a heavy-skulled bone crusher built for processing carcasses rather than running them down. The simultaneous pressure of a changing prey base and new, highly efficient felid competitors may have squeezed the borophagines from both directions. Their prey was changing and becoming harder to catch, and new predators were competing for what remained. There is also evidence from the fossil record of declining species diversity within the borophagines well before the final extinction. The number of borophagine species in North American fossil assemblages drops steadily through the late Miocene, from a peak of over a dozen co-occurring species in the middle Miocene to just a handful by 8 million years ago, and Borophagus alone by 6 million years ago. Epicyon and Borophagus persist in the fossil record through this period of decline, but at contracting diversity and geographic range, until the last records of Borophagus disappear from the fossil record approximately 5 million years ago. The lineage did not go out suddenly. It contracted slowly, species by species, until the last one stopped appearing in the geological record and the 30 million year history of the bone-crushing dogs was over. What Epicyon's extinction makes clear, more than almost any other case in the North American fossil record, is the disconnect between evolutionary success and evolutionary permanence. The borophagines were successful by any reasonable metric: 60 species, 30 million years, continental dominance, and the most powerful jaw of any canid that ever lived. They filled their ecological roles completely and exploited their environment effectively for longer than the entire span of time separating us from the emergence of the first stone tools. They were not marginalized. They were not outcompeted in any straightforward sense during the period of their peak dominance. They were simply incompatible with what the world became when the Miocene ended and the Pliocene began, and the particular combination of physical specializations that made them successful in one world made them unable to adapt quickly enough to a different one. And they left nothing. The small, unimpressive Leptocyon, a fox-sized animal that lived in the understory of the borophagine-dominated ecosystem, probably scavenging and catching small prey, not competing directly with Epicyon for anything significant, produced a lineage that eventually gave rise to the wolves, the African wild dogs, the coyotes, the dingoes, and the dog sleeping on your sofa. Leptocyon survived because it was a generalist. It was not committed to bone crushing. It was not dependent on large carcasses. It could eat what was available, shift its diet when the environment shifted, and persist through the transition that killed the specialists. Epicyon, with its crushing jaws and its lion-weight body and its 10 million year run as one of the most formidable predators on the continent, produced nothing at all. The fossil record keeps returning to the same lesson. The animal most perfectly adapted to its moment is often the least prepared for the next one. The spotted hyena filling the bone-crushing niche today is not descended from Epicyon or from any borophagine. It evolved its hyena-like characteristics independently in Africa from a different ancestral carnivore lineage belonging to the superfamily Feliformia, the cat-like carnivorans, making it more closely related to cats and mongooses than to any canid. The gray wolf that took over the apex predator role in the northern hemisphere after the Pleistocene megafaunal extinctions is not descended from Epicyon. It evolved from Leptocyon's successors through a lineage of medium-sized Caninae that grew larger and more social over the past few million years, eventually producing Canis lupus approximately 300,000 years ago. The domestic dog, the most numerous large carnivore on Earth, with a global population estimated at 1 billion individuals, is descended from gray wolves domesticated somewhere in Eurasia between 15 and 40,000 years ago from the Caninae lineage that Epicyon's lineage never joined and could not have joined because the two lineages diverged tens of millions of years before domestication occurred. Epicyon was the most powerful dog that ever lived. Modern dogs trace their ancestry to animals that Epicyon could have swallowed whole, animals that were hiding in the ecological margins of a continent Epicyon dominated. The fossil record does not favor the strong. It favors the ones that are still there when everything changes. And sometimes, the animal best positioned to survive a changing world is not the one on top, but the one small enough, flexible enough, and unspecialized enough to still be standing when the world it was built for has disappeared. Subscribe. New discoveries about lost species posted every few days.